So we're looking at integration by partial fractions. So partial fractions, which we've covered in chapter 1 of year 13 content, is where we were taking a fraction and we were splitting it up into more than one fraction. So kind of doing the reverse of, for instance, adding fractions. So writing a fraction in terms of partial fractions. And that process is necessary to do certain integrations. So we're going to take a look at this particular example here, where we are integrating this expression. Now, to begin with, if you look at this, we've got a fraction first of all. And in the denominator, we've got the product of three factors, 2x plus 1 and x minus 2, which is repeated. And at first glance, you can see, okay, actually, to even consider integration of reverse of chain rule, it's not obvious here because we don't have product of two functions and we've got fractions involved as well. So whenever we have these kind of fraction involved, it's likely that we are going to have to first of all use partial fractions and then go on to do integration, especially if you can see that the denominator has linear factors, like in this particular case we've got 2x plus 1 and x minus 2. So the first stage here is to actually go and do the separate this into fractions. So let's go and find out what this can be written as. So I'm going to first of all just not worry about the integral here. I'm just going to focus on writing down the fraction 8x squared minus 19x plus 1 over 2x plus 1 and x minus 2 squared, which is repeated. And I can say that this can be written then in the form of a over 2x plus 1 plus b over x minus 2 squared plus c over x minus 2. And then I'm going to go and find out what these terms a, b, and c are. So this is where we are looking at the partial fraction, separated into partial fractions. So we can then go and times both sides by 2x plus 1 and x minus 2 all squared, leading to 8x squared minus 19x plus 1 being equivalent to a bracket x minus 2 all squared plus b bracket 2x plus 1 plus c bracket 2x plus 1 and x minus 2. From here we can go and do some substitutions. We can say let x equals to 2. And if we let x equals to 2, then on the left hand side we end up getting minus 5. And we get minus 5 is equal to this first term becomes 0 plus 5b we get here plus 0, and this then tells us that b is equal to minus 1. We can then go and say let x equals to minus a half, and this gets us on the left hand side, if we substitute that in, we get 12.5, which is equal to 25 over 4 lots of a plus 0 plus 0. So this implies that a is then equal to 2. So we've got a value here, and then I'm going to go and use another substitution here. I'm going to say let x equals to 0, and I know what my a and b are, so I can substitute those values in there as well. Okay, And if we do that, then we get 1 on the left-hand side is equal to 4a plus b minus 2c. And substituting all those values in there then gets us that c is equal to 3. So this first step, we should already know here. It's essentially doing partial fractions here. We're rewriting that 8x squared in terms of 3 separate fractions. So we can say then 8x squared minus 19x plus 1 over 2x plus 1 and x minus 2 all squared then is equivalent to 2 over 2x plus 1 minus 1 over x minus 2 all squared plus 3 over x minus 2. Now, that's the first step. Now we can actually go and start doing the integral. So we can then say that the integral of this left-hand side fraction is equivalent to the integral of each of these individual fractions. Okay, and we are now able to start the process of integration. So it's called integration by partial fractions because that first step involves writing partial fractions. So now let's take a look at each individual integral that we have here. So when we are integrating this first function here, so let's just go and make a note of each of those integrals. Integral of 2 over 2x plus 1 with respect to x. All of them are integrals with respect to x, so I should make a note here, dx, 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 dx. So how do I integrate this? Well, I recognize that this is in the form of a reciprocal function. So this is going to be integration by considering the reverse of chain rule is what we need to use here now. So what does this become here? Well, we know that if we have something which is in the form of this particular function here, we would say, we would try, for instance, let y is equal to ln x. Because that's the form that we know differentiates to get you this particular form here. So we would start by saying y is equal to ln of bracket 2x plus 1. If we do differentiate that, then by chain rule we get dy by dx is equal to 1 over 2x plus 1 multiplied by the differentiation of the inner function, which is 2. So it gets us dy by dx is equal to 2 over 2x plus 1. We can see that this 2 over 2x plus 1 that we have here is exactly what we're trying to integrate. So if we differentiate to get this, then the integral of that should get us back to ln of 2x plus 1. Therefore, we can write down that the integral of 2 over 2x plus 1 dx is equal to ln of 2x plus 1. Likewise, we need to go and integrate to each of those. Okay, so then we can integrate 1 over x minus 2 all squared dx. So this is the second term. So let's just make a note here. That was number 1, this is number 2, and this is number 3. So we did number 1 here, this is number 2. I'll go and write down this second integral. So this we can see here, we've got a bracket to the power of 2. So the first thing which I'm going to do is rewrite this in a slightly different form. I'm going to rewrite this as x minus 2 to the power of minus 2 dx. And I'm going to consider what would have differentiated to give me this function. Because it's got a power, we can see here that this is likely to be reverse of chain rule here. So I'm going to consider what I would have had to have differentiated. So let y is equal to x minus 2. And it would have been a higher power than minus 2, so it would have been minus 1. And if we differentiate that by chain rule, it should get us to the minus 2 as the power. So let's go and differentiate this dy by dx. is equal to minus 1 bracket x minus 2 to the power of minus 2 times by the differentiation of the inner function, which is times by 1, which gets us minus x minus 2 all to the power of minus 2. Now, if we compare them, we can see that we need to adjust this by a factor. We need to times everything by minus 1 to get to the positive integral that we want. Okay, so I'm going to go and times everything by minus 1. Times by minus 1 is our adjustment factor. And as such, we then get x minus 2 all to the power of minus 2. And as we can see here, that this that we get after applying chain rule differentiation is exactly the same as what we are trying to integrate. So we can say if this differentiates to give us that, then this integrates to give us that. So the result of integral of x minus 2 to the power of minus 2 is equal to minus x minus 2 to the power of minus 1. So we've done our second integral and our first integral. Just put a box around them so we can see what our first and our second integrals are. Last thing that we need to do is integrate the final integral here. So it's 3 over x minus 2. 3 over x minus 2 dx. So when we're integrating this, again, we need to think about what function we're going to let y equals that actually differentiates to give us this. Again, we can see this is reciprocal. There's no power on the denominator, so it's going to be let y is equal to ln of x minus 2. If we differentiate this by chain rule, this then becomes 1 over x minus 2 times by the differentiation of the inner function x minus 2, which is 1. So essentially gives us that. But we can see here that this doesn't get us the 3 that we're looking for on the numerator, so we need to apply an adjustment factor here. So if we times everything by 3, put a 3 here, put a 3 here, this then gets us exactly what we want. It gets us to 3 over x minus 2. So if this differentiates to give us that, then this would integrate to give us that. Therefore, the integral of 3 over x minus 2 dx is equal to 3 ln of x minus 2. So there's our final integral. Now that we've integrated each of those fractions separately, we can go back and write down the answer to that. So essentially we're substituting these results into the final integration there. So let's go and see what our integral then becomes. So the integral then becomes, well, let's go and take a look. We've got ln of 2x plus 1 was the first integral. Number 2 was, we then had minus, so take care of that minus there. Can you see we've got a minus there? So make sure you write down the minus first. Minus the answer to the second one, which is, as you can see here, minus x minus 2. So I'll go and write down here minus bracket x minus 2 to the power of minus 1. And then plus our final result, which was 3 ln of x minus 2. 3 ln of x minus 2. Tidy this up a bit. This gets us ln of 2x plus 1 plus, I'll write this in the form of 1 over x minus 2 plus 3 ln of x minus 2. Okay, so here we have our final result. Now this can be tidied up a bit. We can use potentially log laws here. And sometimes the question do ask us to do certain things like that, where you have to combine the log functions here. So as you can see here that this we can then rewrite this as ln of 2x plus 1 plus ln of x minus 2 all to the power of 3 using the power law plus 1 over x minus 2. So here used one of the log laws. And then we can go and say that since we've got the addition of these two, we can apply the multiplication law for log laws. And we can then say it's ln of 2x plus 1 multiplied by x minus 2 all cubed. Modulus of, since ln is always of a positive function, plus 1 over x minus 2 plus the integration constant. So there's our final answer. You would only need to simplify it if the question asked you to write it as a single logarithm, or if it was a show that question. Otherwise, you could have just left it as it was up until here. That would have been fine. So we could have left it there, but if it's a show that and it requires you to collect like terms, you would obviously need to simplify that. All of them, don't forget there is a integration constant that we need to add since it is an indefinite integral.